face a major customer engagement problem. Many shoppers feel frustrated because items are hard to find, stock information is unclear, and the overall shopping experience is slow and inconvenient. As a result, customers visit less often and engagement drops. Our project explores how we can use AI to improve the grocery shopping experience and encourage customers to return more frequently.
Our group has come up with a supermarket shopping application with artificial intelligence implemented into its system. Behind me, you will be able to see what our application will aim to look like. For the first part, we have our quick search function, where customers can type an item they are looking for, and the artificial intelligence will provide a list of items which fit the description, from top rated to lowest rated, based on customer feedback available. Each product will also have an AI summary review attached, so that customers can have a quick overview of the product before purchasing. Beside the item, there will also be an application indicator indicating which aisle the product will be on, reducing the need for customers to look around. For our next part, the application also includes a live stock checking function, where the app will provide real-time updates to the stock count of the desired product the customer may be looking for. Should item be unavailable, the application will then provide an available substitute in the same store, or it will also provide an alternative supermarket the customer can go to, indicating how far away he or she is from the store, so that they may visit the store instead to get the desired product. The application also includes AI-powered recommendations, where the app will analyze the customer's browsing behavior and purchasing history to provide other products the customer may be interested in, increasing consumer behavior. Overall, the application aims to provide a smarter, faster, and more personalized shopping experience.
We firstly rely on the central limit theorem, which states that when the sample size is sufficiently large, typically 30 or more, the sampling distribution of the sample mean becomes approximately normal. This condition is met, which means we can confidently use the t-test for our analysis. Metrics we want to evaluate. These are weekly visit frequency, session duration, and repeat purchase rate. From this, we form 3 hypotheses, all testing whether the app increased engagement. Our first hypothesis is that the app increases weekly store visits. Our second hypothesis is that the app increases session duration. And our last hypothesis is that the app increases repeat purchase rate. In all cases, the alternative hypothesis is that the mean after adoption is greater than the mean before adoption. So we use a one-tailed pair t-test. Each one produced a p-value below 0.05. This means we can reject all 3 null hypotheses. Overall, the results provide strong statistical evidence that the AI-powered app successfully improves customer engagement across all 3 dimensions.
To understand which specific user behaviors contributed the most to the overall improvement in engagement after introducing this AI grocery assistant. And to do this, we first created the change scores for each behavior, and such as the visit frequency, the session duration, and the repeat rate. And we did this by subtracting the before and after values. And then these change scores represent how much each metric improved after the users interacted with the AI feature. So next, we created a realistic engagement index called App Impact, which combines these variable changes with different weights and some noise. So this is to simulate the real life data, right? As this ensures that the model behaves like real business data rather than a perfect mathematical formula. So then in the last step, we ran a multiple regression using the change in the visits, sessions, and repeat rates as predictors, and the engagement index as the dependent variable. And so finally, we standardized the variables so that all 3 predictors were on the same scale, and this would allow us to compare their relative importance directly using this standardized beta coefficient.
Looking at our regression results, the standardized coefficients show very clearly which behaviors contribute most to the improvement in engagement. The strongest predictor is visit change, with a standardized beta of about 0.89. This means that increases in how often users return to the app had the biggest impact on overall engagement after the AI feature was introduced. The next contributor is session change, with a beta of about 0.38, showing that longer sessions durations also significantly boost the engagement, although to a slightly smaller extent. Meanwhile, repeat change has a beta of only 0.07 and it isn't statistically significant. This tells us that while repeat rate increased slightly, it was not a major driver of engagement improvement compared to the other behaviors. After looking at the coefficients, we also evaluated the model fit. Our regression achieved a R-square of 0.821, meaning the model explains about 82% of the variation in engagement improvement. The overall model is statistically significant with a p-value below 0.001, which confirms that the predictors together provide a strong explanation of how engagement changed. Overall, these results show that the AI assistant improved engagement mainly by driving more frequent visits and longer session durations, with repeat rate playing a smaller supporting role.